Okay, so we have finished chapter 7. On page 594, 595, and 596, there are chapter review. And the first part of chapter review is things to know. In this part, the author collect all the necessary and required values and definitions and properties. So this part is very, very important for chapter 7. So you need to read it, study it carefully, and handle all of them. They are all required for the partial exam and the final exam. Especially they are very, very important for you to study calculus. Okay? Very important. Okay, now let's talk about chapter 8. Analytic trigonometry. Analytic trigonometry. The first section, section 8.1, the inverse sine. The inverse sine, cosine, and tangent function. Okay, so trigonometric functions are very different from other functions. You know here, so far we already studied polynomial functions, rational functions, exponential functions, logarithmic functions, and the trigonometric functions. Okay, so you see polynomials, rationals, logarithmic, and exponential, and the trigonometric functions. Okay, so they are all important types of functions, but only trigonometric functions are periodic. See, that's a very special property. Only trigonometric functions are periodic. They have period. If it is periodic, let's make it clear. Trigonometric functions are not one-to-one. Trigonometric function, all 6 trigonometric functions are not a one-to-one function. They are not one-to-one. They do not have inverse functions. In general, for a non-one-to-one function, there's no inverse functions. But it's very important. It's a very, very important function, very important type of functions. We do want to construct its inverse function in some sense. So recall that we know y equal to x squared. This is not a one-to-one function. But if we restrict it to certain interval, to certain special domain, then it becomes one-to-one. So without x greater than 0 condition, this is not one-to-one. But with this condition, it is one-to-one. So it gave us an idea. We are going to restrict trigonometric functions over certain domain. So let's check here. For example, if we have sine function, this is a wave function. It's not a one-to-one. But if we restrict the curve to the interval negative pi over 2 to positive pi over 2, just this red curve, if only just consider the red curve, it is a one-to-one function, right? So that's the function similar to the square function with greater than 1 condition. So we are going to study this function. In this function, y is between -1 and +1 is 1-to-1. For this 1-to-1 function, we can get its inverse. Okay? So for the 1-to-1 function, we can get the inverse. Of course, you can see that you can choose this piece, and you can choose this piece, or you can choose this piece. It's really up to your choice. For different choice, you can define different inverse sign, right? So, but in general, in a common selection, we choose the domain from negative half 2 to positive half 2. Okay, so remember, we are going to just select this. So let me draw it again. So we have pi over 2, 1, negative pi over 2, negative 1. So the graph is this. Okay, we are going to define the inverse sine of x. So let's say this. An equation, let's make this complete. An equation for the inverse of y equal to sine x, x bounded by negative pi over 2 and pi over 2 is obtained by interchanging x and y. So first interchange x and y. The implicit form, we don't know what the solution we have. The implicit form of the inverse function is x equal to sine y. You see, you just interchange x and y. So the implicit form, we just get implicit form. We don't have explicit form. Okay? And in this place, you see y, you see x is between negative pi over 2 and positive pi over 2. Here, y is in the same place of x, so y is between negative pi over 2 and the positive pi over 2. The explicit, this is implicit form. The explicit form is called the inverse sine of x, and is denoted by y is equal to sine inverse of x. Sine inverse of x. That's simple. This is a inverse sine. Okay? So we just create a new symbol. remember that when we have exponential function, we get its inverse, we create a new symbol, logarithmic function to the base. Okay, so once you have a new function, but you don't get you don't explicit write the formula in terms of other functions. You just create a new symbol, right? So y is equal to sine inverse of x. By the inverse function, it just means x is sine y. X is sine y. And in this part, y is in the place of original x. So y is between negative pi over 2 and the positive pi over 2. And x is in the place of y. So x is between negative 1 and positive 1. X is in the original place of y. So x is the value of sine. You see, x is the value of sine. So x is between negative 1 and positive 1. Y is in the range, in the domain of a sine. So y is between negative pi over 2 and positive pi over 2. So you get y is a sine inverse of x. Okay, so let's see the negative pi over 2 to positive pi over 2. If you apply sine function, this is domain, this is range. If you apply sine inverse function, this is domain, this is range, right? So that fits our understanding for the inverse functions pair. We just want to get a value based on the sine inverse. We find the corresponding angle, okay? The value to the angle, that's the inverse sine. So for example, remember that when we have 0, pi over 6, pi over 4, pi over 3, pi over 2, what are the sign? Sine will be 0, 1 over 2, root 2 over 2, root 3 over 2, and 1. 1, remember what is 1? 1 is 2 over 2. 1 is 2 over 2. 2 is a root 4. So it is equal to 1, but it's actually square root of 4 over 2. Okay, this is sine. Then what is the inverse? Inverse, you just read it from second line to the first line. So when you have 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. What is the sine inverse? 0, pi over 6, pi over 4, pi over 3, and pi over 2. Okay, so we just switch the positions of two rows, so we get the one is about the sine, one is about inverse sine. So this is the stuff, and we know that sine negative x is negative sine of x. Sine is an odd function. Inverse sine is also an odd function. Inverse sine is also an odd function. So if you get the negative, for example, negative 1, negative root 3 over 2, negative root 2 over 2, negative 1/2, 0 is also is already included. So sine inverse of x, it will be negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6. So you put them together. You put them together, you get this one. They share the same value, but with different sign on two sides of zeros. So that's why you only memorize the positive part, negative part, you find it by the mirror. Okay, so this table is on page 605. So you memorize this table. This table is required. It's just another understanding for the same correspondence. And another thing, we only memorize up to pi over 2 because for the sine inverse, it is restricted to the negative pi over 2 and the positive pi over 2. Outside it, there's no value. Okay, it's undefined. Okay, so this is the memory of the tables. So you just, whenever you get an angle, sine inverse of negative 1/2, you move this negative sign forward. So you get a negative sine inverse of 1/2. Sine inverse 1/2 is pi over 6, so it's negative pi over 6. Of course, if you can memorize it and you write down the answer directly, there's no problem. Okay, so this is the definition, sine inverse. This is a definition. We know that the inverse and the original function have the property that their composition is identity function. The composition is identity function, okay? So we want to find some problem which are involved to those two properties, especially for the trigonometric function. Sometimes you need to be very careful. For example, sine inverse of sine of pi over 8. You cancel them, you get pi over 8. This direct computation is correct because pi over 8 is in the domain. Pi over 8 is in the range. It's in the range of sine inverse. It is in the range. The thing will be different if we have sine inverse of sine of 5 pi over 8. If we get this one, first I'm going to say it's not equal to 5 pi over 8. It is not equal to 5 pi over 8. Okay, so that's one thing. Because 5 pi over 8 is not in negative pi over 2 and positive pi over 2. Why we always emphasize negative pi over 2, positive pi over 2? Because that is the range of sine inverse. That's a target sine inverse can reach. So that's why here we have to emphasize what is the x. So here the x should be in the -1 and +1 because f inverse has domain -1 and +1. It's in the domain of f inverse. Here this x should be in the range of f inverse because f inverse is a sine inverse. Sine inverse can only reach negative pi over 2 to positive pi over 2. It cannot be any other values. Okay, so for this one, if it is not the case, then what is the value? Check here. This is pi over 2. Here is pi over 3. 3 pi over 2, 3 pi over 8. This is 5 pi over 8. So from the geometry, you know that this is a like up-down process. So sine 3 pi over 8 is equal to sine 5 pi over 8. Okay, So in this part, there are two values. They share the same angle. There are two angles. They share the same value. So this problem, we start from 5 pi over 8. This is 5. We start from 5 pi over 8. It is equal to sine 3 pi over 8. And when you replace 5 pi over 8 by 3 pi over 8, this angle is in the range negative pi over 2 and pi over 2. And then this one is what it is. It's a 3 pi over 8 because it's in the range. Okay, it's very important. You have to find the stuff in the range. Okay, so how do we understand, how do we get this angle? It is actually the reference angle. It is actually the reference angle. You see? If here's a 5 pi over 8, then this part will be 3 pi over 8, the reference angle. And in the reference angle, this in the second quadrant, you share the same value. Remember that sine 5 pi over 8 is equal to sine 3 pi over 8 because 3 pi over 8 is the reference angle and 5 pi over 8 is in the second quadrant. It's in the second quadrant, and you have the reference angle, then they equal to each other. Okay, so once you can get the reference angle is always acute. Acute means it's between 0 and pi over 2, so that's good, right? Okay, let's try more. Let's try more. Let me find more exercise. Okay, for example, sine inverse of sine 9 pi over 8. Sine inverse of sine 9 pi over 8. First, you get 9 pi over 8. This is pi plus pi over 8, so this is 9 pi over 8, right? This is a 9 pi over 8. Then the reference angle, is pi over 8. Reference angle is pi over 8, but it's in the third quadrant. 9 pi over 8 is in quadrant 3. So what we have? Sine is negative, so sine 9 pi over 8 is negative sine pi over 8. Sine 9 pi over 8 is equal to negative. Negative comes from quadrant 3. Sine pi over 8 it comes from the reference angle. Okay, so sine inverse of sine 9 pi over 8 is equal to sine inverse of negative sine pi over 8. Remember, it's an odd function. You just move negative sign forward. And then this is pi over 8, so it's a negative pi over 8. Because whenever you get a reference angle, it is always an acute angle. This angle is always in the domain, in the range. It's always in the range. Okay, reference angle is very important in this application. You must find the reference angle first in order to get the answer, correct answer. Okay, so let's check other composition. sine of sine inverse of 0.5. Sine of sine inverse of 0.5. Then this one, 0.5 is well defined, and sine inverse and sine after composition is just 0.5. Okay, so it's a direct, you just apply this composition is identity composition. And if you have sine of sine inverse of 1.8, 1.8 is not in the domain of sine inverse. Sine inverse can only take value between -1 and +1. But here have 1.8. This is undefined. Because 1.8 is outside of the domain. There's no way to justify it. There's no way to modify it, not to justify. There's no way to modify it. It's not like the previous one. The previous one, you can still modify it by checking the reference angle. But here, there's no way. It's off. It's not in the discussion range. Okay, this one is undefined. So again, if we have sine inverse sine, we need a reference angle. If we have a sine of sine inverse, we only need x between -1 and +1. Okay, so these two things are slightly different, because here you need to check the range. Here you have to check the domain. Okay, so this is a inverse sine. Inverse sine. Do I show the? Yeah. This is the inverse sine. And if we draw the graph of a inverse, this is sine. This is sine. Y equal to sine x. Remember the graphs of inverse function and the graphs of the original functions are symmetric about the line y equal to x. And if you sketch it, it looks like this. So the graph of sine inverse is a vertical stuff. Remember when we talk about the wave function, sine function, we always say the graph is a little bit flat, so it's horizontal. But when you flip it, exchange x and y, the graph will be a little bit vertical. So this is a graph of a sine inverse inverse sine. Okay. So that's the graph. The graph, and in the graph you can also clearly see the domain and the range. Okay. So that's the evaluation combination graph and evaluation combination graphs. And be careful about this tricky problem, especially when we talk about the reference angles. And you have to understand the reference angle. You have to understand the quadrant. Okay. after we discuss the sine function, we can discuss the cosine function. The cosine function, the inverse of the inverse cosine. Cosine. We find the inverse sine by cutting the graph, and we find the inverse cosine also by cutting the graph. So this is a cosine, the graph of cosine. This time we cannot cut from negative pi to positive pi 2. If we cut this way, it's still not 1-to-1. So we will cut it from 0 to pi. We choose this piece. So cosine x over the domain 0 and the pi. This piece is a 1-to-1 function. Over this domain, the function is 1-to-1. Okay, so y is cosine inverse of x. It's the inverse function of this 1-to-1 function. It just means x is equal to cosine of y. Okay, so here you see y is between 0 and the pi, x between -1 and +1. Okay, cosine 0 is +1, cosine pi is -1. So again, 0 pi, if you apply cosine function, it's from -1 to +1. If you apply cosine inverse function, from -1 +1 to 0 pi. So the back and forth properties. It's very similar to the sine and the sine inverse, but the angle interval is different. The angle interval is different. Be careful about it. And because of this, and if we sketch the graph, of sine inverse, it will be like this. Remember, the graph are symmetric about line y equal to x. So you see here, it's like that. Yeah, it's good. It's good. It's not bad. So the graph of inverse cosine is like a piece of arc standing on the x-axis. This function, it has, you see here, it has an x-intercept 1, y-intercept pi over 2. Okay? It's not even function, not odd function. This graph is not symmetric with whatever property. It's not symmetric with respect to y-axis. It's not symmetric with respect to the origin. No, it's not even not odd function. Okay? Be careful. And we get the value table. Okay? Let's try to get the value table. Again, we're going to start from the cosine. And cosine 0, pi over 6, pi over 4, pi over 3, pi over 2. Okay, so what's next? You see 6, 4, 3, 2, and then you get 3, 4, 6. It's symmetric. And then you reach pi. Numerator is, here's a pi over 3. Now it becomes 2 pi over 3. 4, 3 pi over 4. 6, 5 pi over 6. 5 pi over 6. So 6, 4, 3, 2, 3, 4, 6. It's a symmetric. And the cosine will be 1 root 3 over 2 root 2 over 2 1 half 0. Then you get a negative 1 half negative root 2 over 2 negative root 3 over 2 and negative 1. It's also symmetric. This is for the cosine. If you want to get the evaluation table for the inverse, you just read from the second row and then you get the corresponding value for the first row. Okay? Now let's copy it again to emphasize. So you get 1 root 3 over 2 root 2 over 2 root 1 over 2 and 0 negative you get symmetric part of negative root 3 over 2 and negative 1. And then we get cosine inverse of x. We'll get 0 pi over 6 pi over 4 pi over 3 pi over 2 and 2 pi over 3 3 pi over 4 5 pi over 6 and the pi. Okay, so this is a table on page 609. Read this table and be careful about the pattern. Okay. Technically, we always memorize the sine cosine. We don't memorize the cosine inverse and sine inverse. We don't have enough time to memorize all these formulas. So just memorize the one and get the other one based on this formula. Okay? And similar thing. We have a composition of an inverse function and original function. You get identity function. But this time, if we apply it to cosine, here x is in the domain, so x is between -1 and +1. If you have f inverse of x, you see f inverse of x is in the domain. Here you get f of something is equal to x, so x is in the range. Okay, so be careful about this. Be careful about this. Okay, now let's check. Let's do exercise about this evaluation. So find the exact value of a cosine inverse of cosine pi over 12. This is in the cosine inverse cosine. It's in the range, so it's just pi over 12. Second, if we have cosine inverse of negative 0.4. This is also in the domain of a cosine inverse, so it's just directly negative 0.4. Okay. Next, if we're looking for the cosine inverse of a cosine negative 2 pi over 3, cosine inverse of cosine inverse of cosine of a negative 2 pi over 3. So it is it's not equal to negative 2 pi over 3, first of all, because this is not in the range 0 pi. It's not in the range of 0 pi. But we know that the cosine is an odd function. Cosine is an even function. cosine negative x is cosine x. Cosine negative x is cosine x. So you do what? You apply the even property. You cancel this negative sign. You cancel this negative sign. Now it is in the range 0 pi. So it's equal to 2 pi over 3. It is equal to 2 pi over 3. So now let's see a problem. What happens if your angle is random? For example, if you have a random angle, how do we modify it so that we can evaluate? Let's try to find some examples and we understand it. Okay, so for example, cosine inverse of cosine negative 5 pi over 3. Negative 5 pi over 3. So if you have an angle, you're going to plus minus 2k pi and make it in the 0 to pi. So first, x, you plus or minus 2k pi to x, so that x plus 2k pi is between 0 and 2 pi. Okay, so for example, let's look at cosine inverse of a cosine, for example, 6 over 13 pi. You just minus 2 pi, subtract 2 pi, right? 13 pi over 6 minus 2 pi is pi over 6, because this is 12 pi over 6, so it's pi over 6. Okay, very good. Pi over 6 is in the 0 pi, so it's equal to 6 pi. That's good. And second, the thing is that maybe after you subtract a certain multiple of 2k pi, it is still not in the 0 pi, like this. Cosine inverse of a cosine of a let's make 19 pi over 6. 19 pi over 6 minus 2 pi is 12, right? It's 12 pi over 6. 19 minus 12 is 7 pi over 6. It's 7 pi. Cosine inverse of a cosine 7 pi over 6. It's bigger than pi. Then what's going on? You continue the subtraction. Let me see what is going on. Yes, you continue the subtraction by 2 pi. So 7 pi over 6 minus 2 pi. What is it? It's 7 minus 12. It's negative 5 pi over 6. See? 7 pi over 6 minus 2 pi, you get a negative 5 pi over 6. And then you apply the even property. You will remove this negative sign. You get 5 pi over 6. Perfect. 5 pi over 6 in this moment is in the range 0 pi, so it is equal to 5 pi over 6. Okay, so the best case is that it is already in the 0 pi. Then you just directly write the answer, or you subtract or add certain multiples of 2 pi so that it is in the 0 pi, the value is in 0 pi, then you write the answer. Or after subtraction or addition with a multiple of 2 pi, you still have an angle. It's not in the range 0 pi. You subtract or add, you subtract 2 pi. You will change it to be the negative angle. This negative angle, you apply the even property of cosine. Even property, you remove the negative sign, then this angle will be in the 0 pi. Okay, so this is the complete discussion. So let me make this clear. So first, you understand this process. Cosine inverse cosine of pi over 6 is pi over 6. And second, you understand this one. How do you get pi over 6? And third, you understand this. How do you get 5 pi over 6? So those 3 different cases cover all the possible cases. Okay? So make sure you understand all the steps and get the correct answer. The important thing is that the output should be in the 0 pi. You cannot have some number, some angle outside 0 pi. That's not in the range of cosine inverse. Okay? And this is a discussion. Okay, C, D. Cosine of cosine inverse of a pi. This one is tricky because it's so confusing with the cosine and cosine inverse. Cosine can be applied to pi, but cosine inverse cannot be applied to pi because pi is approximately 3.14. It's greater than 1. So cosine inverse of pi is undefined. Cosine inverse of pi is undefined. Then this value is undefined. Okay? So cosine of pi is -1. Cosine inverse of pi is undefined. So they are so close to each other, but this one is bad, this one is okay. Right? Very good. Then the rest of the part will be very close to the inverse sine. So you just do the evaluation, and we already know the graph, and we can combine sine inverse with sine, cosine inverse with cosine. The third one, the inverse tangent. Inverse tangent. Remember, tangent function is different from sine cosine. It has several pieces. They're all identical. Okay, so you will naturally select the middle piece. This time there's no other best. There's no other better selection. We just select the middle piece. We select the middle piece and consider it as a proper selection of a tangent function. Okay, so we choose tangent of x between negative pi over 2 and positive pi over 2. And then we define its inverse. So y is tangent inverse of x if and only if x is tangent of y. Okay, y is tangent inverse of x if and only if x is tangent of y. So y is in the place of x, so y is between negative half a 2 and the positive half a 2. X is in the place of y, x is between negative infinity and the positive infinity. So negative half a 2, positive half a 2, to infinity, negative infinity, positive infinity. You have a tangent x, go back, you have a tangent inverse of x. Okay? So that's a tangent inverse. And since we select this curve, and remember the graph of a tangent inverse and the tangent, they are symmetric about the y equal to x. So it's a tangent function if we get it's a tangent inverse function. This becomes tangent inverse function. The graph is horizontal. It has two horizontal asymptotes. It has two horizontal asymptotes. So naturally this graph has two, because you flip the vertical asymptote to the horizontal. Okay, so this is a tangent inverse. And you can find a similar table of the values. It's on the page 612. You get the same values. And then you are supposed to evaluate the okay, let me stop this video and I open another short video to finish this section. Okay, so I will discuss the table 3 on page 612, and we will do more examples and finish this section. Okay, I stop this video for now and I will start another short video.